Imagine moving model data inside a GPU. llama.cpp fixed how that copy starts on one path. On arc70, the reported rate jumped dramatically.
The reported rate rose from 20.21 to 158.19 gigabytes per second. That is a large change in this one conversion path.
Other measured formats stayed flat, so do not read this as llama.cpp becoming 8 times faster overall.
The fix changes a copy kernel, meaning the GPU routine that performs this conversion. It changes launch sizing, not models or APIs.
Throughput means data moved each second. Here it is copy path gigabytes per second, not generated tokens.
The standout conversion begins with Q40. That is the source label for the input format being copied.
It ends with F32, the source label for the output format. Together, Q40 to F32 names the exact conversion to test.
We need 3 answers. What shipped? Why does launch sizing matter? And should this change your next GPU test?
Release B10456 arrived August 17th and points to pull request 27160. Those identifiers help you verify the fixed code.
Think of SYCL as the route used to program the GPU. The pull request labels SYCL, a GPU programming language. This fix belongs to that route.
The release calls this a quantized copy kernel. Here, quantized means it handles the data formats the release calls quants, including Q40.
GPU launch size is the thread and block count assigned to a job. The fix now scales those counts with quant size.
Pull request 27160 was approved, then merged into llama.cpp master, with one commit on August 17th. That places the focused fix in master.
Release B10456 points to commit F275595. Use that commit when checking whether your build contains the sizing change.
A backend is llama.cpp's route for running work on particular hardware. This claim covers the SYCL backend's quantized copy path.
Picture a job sized for many workers, but launched with the wrong worker count. The fix aligns launch size with work size.
Imagine quant-sized work arriving at a loading dock. The worker groups should grow or shrink with that load. Without proportional sizing, the launched worker count can sit below or above the amount implied by the job.
Too few launched workers is under subscription. The stated fix reduces that mismatch by scaling the launch with quant size.
Too many launched workers is oversubscription. Proportional sizing also reduces this opposite mismatch.
This scaling is called proportional launch sizing. As quant size changes, thread and block counts change with it.
One conversion can benefit while others stay flat. That is exactly the uneven result reported here, so test paths separately.
The loading dock only explains the sizing idea. The evidence is still 2 measured copy rates on named hardware.
Launch efficiency is not whole model speed. Keep it separate from copy throughput and complete inference, meaning model execution.
Before the fix, arc70 copied this Q40 to F32 path at 20.21 gigabytes per second. That is the slower baseline.
After the fix, the same arc70 conversion reached 158.19 gigabytes per second. That is the faster post-fix result.
The result is much more copy throughput on this path. It does not mean the model produces tokens faster.
The jump from 20.21 to 158.19 is substantial. It applies only to this reported conversion.
Practically, the fixed path moves almost 8 times as much data each second. That makes this exact arc70 conversion worth retesting.
The sources provide no generated text speed, waiting time, or complete model benchmark. Those real workload outcomes remain unmeasured.
The release names Q40 to F32 as the largest gain. It says the remaining quant path stayed flat. For you, that limits the documented gain to the named path. A reviewer added a B60 check in the pull request discussion. Treat it as supporting evidence, not the release headline.
Before the fix, that reviewer reported 9.08 gigabytes per second for Q40 on B60. This is the B60 baseline.
After the change, the reviewer reported 104.73 gigabytes per second on the same B60 path. This is the B60 post-fix result.
On B60, The contributor reported a jump from 9.08 to 104.73 gigabytes per second. That result is still path-specific.
The reviewer reported no impact on other data types, so the B60 comment also argues against expecting a broad speedup.
We now have two hardware examples, arc70 in the release, and B60 in a reviewer comment. Neither is a universal GPU result.
Both examples show large Q4 zero-path gains after proportional sizing. Their different starting rates show why hardware names matter.
These measurements use different hardware and evidence contexts. Averaging them would invent a result neither source reports.
The repeated gain makes the fix interesting. The repeated flat path warning means builders must verify their exact conversion.
Neither verified page says llama.cpp is faster overall. The reported changes describe specific copy paths only.
The release says the rest of the quant paths were flat. Keep that sentence beside every dramatic performance number.
The sources provide no price, power, or cost comparison, so these speed measurements cannot establish affordability.
A workload is the exact model, prompt, context length, and application being tested. The sources name none, so workload fit remains unknown.
The verified gain belongs to SYCL. The packet reports no matching result for CUDA, Vulkan, OpenVINO, ROCm, or CPU builds.
The pull request contains one commit. That supports a focused fix, but it does not prove every workload changes.
A useful benchmark label includes backend, conversion, hardware, and metric. Preserve all four when you repeat this result.
Do not ask only, are these GPUs fast now? Ask whether your workload reaches this improved copy path.
First, confirm that your llama.cpp build uses SYCL. The verified change is tied to that backend.
Second, check whether your test reaches the quantized copy operation. General model execution includes much more than this kernel.
Third, identify the Q40 to F32 conversion. That path has the largest reported arc70 improvement.
Fourth, measure copy throughput in gigabytes per second. Do not replace it with text generation speed or total waiting time.
Fifth, record the hardware. arc70 supports the release numbers. B60 is a separate reviewer-reported check.
If SYCL, the copy operation, and Q40 to F32 all match, retest. This release says the old result may be obsolete.
If you use another quant path, the release documents, no uplift there. Expecting the standout gain would exceed the evidence.
Price, power, and end-to-end model results are still missing. This supports renewed testing, not a finished purchase recommendation.
The update is specific, llama.cpp, fixed SYCL, launch sizing, and reported an exceptional Q40 to F32 copy gain.
A low-level launch mismatch can dominate one operation. Neighboring quant paths can still remain unchanged.
Backend benchmarks need labels. Remove the path or metric, and an accurate measurement turns into a misleading headline.
Next, look for independent tests, naming SYCL, Q40 to F32, hardware, and gigabytes per second. Those details make comparisons usable.
Also look for complete model tests reporting generated text speed, waiting time, and total workload time. This packet reports none.
Watch whether future changes improve more quant paths. This release says the remaining paths stayed flat.
These named GPUs are now more interesting for llama.cpp testing. The evidence still does not settle a buying decision.
One merged launch fix produced one dramatic arc70 path and one supporting B60 report. Subscribe for the next measured result.